Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be talking about today is notes 12.3, which is over the ideal gas law. But before we go into that, I'd like to take a few moments and try that bell work problem, which is over the combined gas law. Alright, now that you've had time to try that, let's go over and look at the objectives and goals for today. So let's get started. Subobjective 1 says you need to be able to convert units of pressure, volume, temperature, and moles. Okay, really important in this unit to be able to do that. That's been an objective for every one of our lessons so far. Subobjective 2, be able to plug in the correct values for the ideal gas law. And our goal, be able to solve for any variable in the ideal gas law. So, in this whole unit, what we've been talking about is we've been talking about relationships among pressure, volume, moles, and temperature. And what we did last lesson is we talked about the combined gas law. The combined gas law shows, all right, if I have a container of gas in one situation and then I move it to another situation, how do my variables change? All right? Well, in this lesson, we're not going to be going over like a change. We're not going to be taking a balloon from one place to another, but we're going to be looking at the relationships among our pressure, volume, moles, and temperature. Now, what has been discovered is that in any sample of gas, all four of these variables are dependent upon each other. If you wanted to know the volume of a certain balloon, you would have to know the temperature of the gas. So if you wanted to know V, you would have to know T, you'd have to know the pressure, or P, and you'd have to know the quantity of gas particles, also known as N for moles. Okay, so when we put all of those variables together, what we get is we get PV equals nRT. Here's what this means. Okay, this is called the ideal gas law. Okay, this means if I take the pressure times the volume of my gas and set it equal to the moles times R times T, or my temperature, I can solve for any other variable. Okay, this is always true. Okay, this is called the ideal gas law. This is for gases under ideal conditions. Now you might say, well, wait a minute, well, what is that R? I've heard about pressure, I've heard about volume, I've heard about moles or N, I've heard about temperature, but what's this R value mean? Okay, R is called the ideal gas constant. All right. Now there are tons of R values. So this is a table of values that's on your notes page. These are all the different values you can plug in for R. Okay, there's 12 up here. Now I don't do that to intimidate you. I do that to show you that there's a ton of values for R. We need to make sure we use the right one. So you don't need to learn all of these. But, and this is a very big, important but, you have to make sure that your units are in these values. So in other words, your pressure has to be in atmospheres. Your volume has to be in liters. So if you're going to use this equation, PV equals nRT, pressure has to be in atmospheres, volume has to be in liters, temperature has to be in Kelvin, and N has to be in moles. If you have done all that, then you can use this value for R, 0.0821. These are the units of that R value. Liters times atmospheres divided by moles times Kelvin. All right? And you might be like, okay, great, let's use that value. Now I'm going to show you that value is technically right here. Okay, it just includes more decimal places. Now, why is this important? So you might be wondering, well, what if I don't do that? What if you didn't use your pressure in atmospheres, for instance? What if you used it in torr or millimeters of mercury? Well, if that was the case, you would have had to use a R value that has torr in it, which is right here. So you'd have to use 62.36367. Not 0.0821. All right? So that's why it's super important for you to always have your pressure, volume, temperature, and moles in these units. Because if you don't, if you exchange one of those units for something else, you'd have to use a different R value. All right? So in order to keep you guys from having to use all these different R values, I've said, hey, let's just always change our units to these, so that way we always use the same R value, which is 0.0821. All right, so again, the ideal gas law is an equation that relates pressure, volume, moles, and temperature to something called the ideal gas constant, which is R. In other words, if I take my pressure times my volume and divide by my moles of gas times my temperature, I will always get R. Remember in our last notes, our last unit, our last notes page, 12.2, where we had the Gas City and then we had the Marion or the Pikes Peak instances? Remember in the combined gas law we had P times V over N times T equals R. That's that R value. All right, that's always true. That's why we can use that value all the time. That's why it's called a constant. Okay, this value is never going to change. All right, so we're going to go ahead and I'm going to show you how to do this problem. Let me get the screen set up and then we'll get going. All right, so let's go ahead and get started. So it says how many moles of nitrogen gas are in a tank that has a pressure of 30 atmospheres, a volume of 200 liters, and a temperature of 25 degrees Celsius. So what I'm going to do is I have to use PV equals nRT. All right, that's my equation. I've got to use that one. Now I have to make sure that my pressure is in atmospheres, my volume is in liters, my moles of gas, or in, has to be in moles, and my temperature has to be in Kelvin. Otherwise, I can't use that 0.0821 for R. So I'm going to verify all of that. My pressure, I've got 30 atmospheres. It's in atmospheres, I'm good. I've got 200 liters, so my volume is good. And my temperature is in 25 degrees Celsius. Remember, I can't use Celsius. I have to change it to Kelvin. So I take 25, add it to 273, and that will give me my Kelvin. And I am solving for moles, so I'm going to leave N open. So when I plug in my values, it should look something like this. 30, is my pressure. My volume was 200 liters for my problem. I'm going to plug in 0.0821 for R, and my temperature is 298 because 25 plus 273 is 298. Now I solve these equations on both sides, and I get that 6,000 is equal to N times 24.5. Well, now I divide both sides by 24.5, and so I'm going to have 6,000 divided by 24.5 is equal to N, which means my N value is going to be 245 moles. So in other words, if I had a tank of this nitrogen gas, it would have 245 moles of gas inside of that container. All right? So let's go ahead and let's try another one. So it says, what's the volume of a tank of gas which contains 92 grams of carbon dioxide gas with a pressure of 600 kilopascals at 40 degrees Celsius? All right, so this one a little bit more difficult. So we've got, PV equals nRT. That's our equation. And remember, I've got to have my units in the I have to have all of my values in the proper units. So, is pressure in atmospheres? Well, this is technically my pressure. That's in kilopascals. I cannot use 600 kilopascals unless I go and search and find a different R value. If I want to use 0.0821 for R, that has to be in atmospheres. So I'm going to change that over. Well, I don't know if you guys remember this or not, but there is 101.3 kilopascals for every atmosphere. So if I want to change 600 kilopascals to atmospheres, I have to take 600 and divide by 101.3. So I'm going to do that. And I get 5.923. So my pressure is 5.923 atmospheres. Just to save room, I'm not going to include the units. My volume, see, does it give me that volume? No, it says what is the volume. That's what it's asking me for. So I'm going to leave that in as V equals N. Well, this gives me grams. All right? It doesn't give me moles, but I know how to change to grams, or excuse me, change from grams to moles. So, since I'm given 92.5 grams, and I know that it's carbon dioxide, well, what's the formula for carbon dioxide? That's right, should be CO2. Since I know the formula for it, that means I can find its molar mass, and if I know its molar mass, I can change from grams to moles. So I'm going to find moles of CO2. Well, in order to do that, I'm going to do 92.5 divided by the molar mass of CO2. What is CO2's molar mass? All right, should be 44.01. So when I divide those, I get 2.1018. So I'm going to have 2.1018. Then I multiply by my R value. Again, my R value is 0.0821. Then I multiply by my temperature. Okay, so here's my temperature value. It's 40 degrees Celsius, but remember, I can't use Celsius. I have to change it to Kelvin. So I'm going to do 40 plus 273. And that gives me 313. Now I'm going to solve this for V. So I'm going to solve this side of my equation first. Then I'm going to divide by 5.923, and that should give me my value for my volume. So I've got 2.1018 times 0.0821 times 313. And that gives me 54.0106. And this is going to be 5.923 V. So now I'm going to divide both sides by 5.923. And I get that my volume is equal to 9.12. Now, what would the units of this be? Take a minute, think about that. That's right, it should be in liters. Okay, and that's the reason why, okay, is because since I used this R value of 0.0821, remember, in order to use that value, my pressure has to be in atmospheres, my temperature has to be in Kelvin, my N has to be in moles, and my volume has to be in liters. So that's why this value for liters is the correct value. Okay, so that's the correct unit. All right, what I want you guys to do now is I want you to go ahead and give these two problems a try on your own. The answers will appear for you on Edpuzzle, so you can check your work. Again, if you have any questions, don't hesitate to ask. Again, the objectives, the things that you should be able to do is you should be able to, first of all, you should be able to convert between units of pressure, volume, temperature, and moles. You should be able to plug in values into the ideal gas law. And your goal, the thing you should be able to do, is you should be able to solve for any variable in the ideal gas law or using PV equals nRT. If you have any questions, don't hesitate to ask. Again, thanks for watching.